Hello there. We are Stats Group, Bryn Gorman, Tommy Larson, Brendan Kelly, and Joey Pickles. And we are talking about part one of the project where we did linear regression analysis on movie data sets and wanted to predict profitability in regards using budget primarily. So one of the biggest problems we had was we had a lot of outliers and significant points, that observations that were in our test set that were fine and they were okay, but outliers and influential points are one of the most statistical issues that everybody knows about. Most people don't really know how to deal with. Most statistics like means, standard deviations, and correlations are highly sensitive to outliers. And since these assumptions of common statistical analysis, like linear regression and ANOVA, are also based on these statistics, outliers can have a huge impact on our analysis. Despite all of this, as much as you would like to, it is not acceptable to drop an observation that's an outlier. They can be legitimate observations and are sometimes the most interesting ones. It is important to investigate the nature of an outlier before deciding. So we wanted to share an example from our group where we were stuck in the predicament on whether to drop an influential observation from our data set. Our data set included movies released in the United States between 2011 and 2016 and looked at how the movie's budget affected its revenue. Before running the linear analysis, we analyzed the data and looked for any potential outliers or influential points. The initial scatter plot showed a clear outlier. The movie Star Wars Episode VII, The Force Awakens, has the highest budget, you'll see right here. It's the highest budget and a DGR that does not appear to fit the trend of the rest of the data. Star Wars generated an extremely higher revenue than any other movie with a similar budget. When looking at the residual and leverage plots, we found there to be several observations that met the criteria of being either a residual or high leverage point. Star Wars met both criteria.
Despite multiple extreme outliers and high leverage observations, these points are not necessarily influential. To access influence, we build a scatter plot using fixed distance. When accessing the top 5 influential movies in our data set, Star Wars unsurprisingly was the highly influential relative to the rest of the data. Star Wars more than 4 times as influential as the next 4 highest influential points, and it's the only observation that had a Cook's distance score of over 0.5. Curious as to why Star Wars was such an outlier, so we did some research on it and found this article. And it said that Star Wars Episode VII is now the top grossing film at the domestic box office, which is interesting. It ranked above Avatar, Titanic, Jurassic World, and The Avengers.
Damn!
Which is super interesting.
So we saw that the observation was influential and illegitimate, so we wanted to get it out of there. And we ran a linear regression with and without the Star Wars observation in our data set. So with that outlier in it, we had an R-squared of 55%. Actually, the R-squareds were the same. Both were 55% of the variability explained. Our standard error and our standard sum of squared error both had significantly dropped when we took Star Wars out of the data set. There was better predictions, there was less error, less residual error in the model, and so taking Star Wars outlier out actually did help us significantly. There's about 3 dropped and standard error, and then some of the squares there changed by about 330,000. So that was really good. It helped us with our predictions. And so have a good summer, best chance. We all say bye. We love you.